For fleet owners, the decision of buying, using, and selling cars is very complex, involving aspects like price, mileage, fuel costs, carbon emissions, travel demand, maintenance cost, and so on. With, with technology, we aim to simplify fleet decarbonization by providing data-driven solutions for robust decision-making. The first challenge is determining the values of the decision variables while adhering to the constraints that minimizes the cost. For example, the number of vehicle to buy in a particular year is a decision variable, and limited carbon emission in a year is a constraint. To address this, we model the problem as a constraint optimization task. To solve this, we use the Gurobi optimization solver. But non-linearities in the constraint in the formulation make the optimization process very slow. This brings us to the second challenge, which is efficient computing. Here's where our innovation comes in. We introduced the preheating stage, which is basically a simplified version of the original problem. For the preheating stage, we simplify the nonlinearity by substituting one of the variables with a constant and ensuring that the solution remains feasible. With this foundation, we then proceed to solve the original problem using the decision variable values derived from the preheating stage as our starting point. This approach significantly reduces the time taken to solve the optimization process and increases the accuracy as well. With preheating enabled, we can reach around 172.45 million in just 10 seconds, whereas without preheating, we reach 177.67 million, which is 5 million more in an hour. This means that fleet owners can easily examine more possible combinations in significantly less amount of time. Given this theoretical setup, the final challenge is to build a scalable, easy-to-use prototype, which we built using Streamlit Python framework. And here it is. This is the input section where we can upload the input CSV files. In this button, we can edit and view the input tables. Here we can set the constraint parameters, for example, like these, the maximum vehicle usage duration. Here we can set the model specific parameters such as turning off or on the preheat or setting time limits. Here we can see all the runs sorted by the total cost. We can view details of a particular run and the key statistics of the decision variables here as well. We also support worm stairs, allowing the optimization process to resume from where this run ended, and possibly by tweaking these parameters. A worm state creates another separate run. It doesn't override the previous run. Thank you.